Welcome to a gentle visual journey into the beautiful world of mathematics. Today, we are going to explore a fascinating concept, how to multiply sets, otherwise known as the Cartesian product. Let's begin at the very beginning with step 1, the basics of sets and pairs. Before we can multiply anything, we need to ask, what is a set? Simply put, a set is just a collection of distinct objects. For example, imagine a set called set A that holds the numbers 1 and 2. We write this mathematically as A equals, to the bracket, 1, 2. Next, we must ask, what is an ordered pair? An ordered pair is exactly what it sounds like, a pairing of two items where the specific order truly matters. We always write these inside parentheses just like this, x, y. To understand why order is so important, just think about how the pair 1, apple is fundamentally different from the pair apple, 1. Now that we have our building blocks, let's explore step 2. What is the Cartesian product? The definition is quite elegant. The Cartesian product of two distinct sets, let's call them set A and set B, is an entirely new set. This new set contains all of the possible ordered pairs where the very first item comes from set A and the second item comes from set B. When we want to represent this, we use a special symbol, A cross B, which we read out loud as A cross B. In formal mathematical notation, it looks like this. A cross B equals, to the bracket, A comma B, where A is an element of A and B is an element of B. This simply means we are gathering every possible combination into one new family. Let's bring this to life with step 3, our finite example. We will use two small finite sets to see exactly how this beautiful pairing works. First, we have set A, which represents numbers. Specifically, our set is A equals, bracket, 1, 2. Next, we have set B, which represents letters. This set is B equals x, y, z. To find our Cartesian product, A cross B, our mission is to pair every single number found in set A with every single letter found in set B. To make this perfectly clear, we are going to look at 3 wonderful ways to visualize this process. Let's look at our first method, Visualization 1, the tabular grid or matrix. Imagine drawing a simple table. Along the top columns, we place the elements of set B, x, y, and z. Down the side rows, we place the elements of set A, 1 and 2. Where these rows and columns intersect, we form our new pairs. Looking at the row for number 1, it meets the columns to create the pairs 1x, 1y, and 1z. Looking at the row for number 2, we find the pairs 2x, 2y, and 2z. It's a perfect organized grid of harmony. Now let's explore another pathway with Visualization 2, the tree diagram. We begin at a single starting point and draw branches for our first choices from set A, the numbers 1 and 2. From the number 1, we let the tree branch out further, reaching towards the letters x, y, and z. This delicate branching creates our first set of pairs, like 1y and 1z. We do the exact same thing from the number 2, branching out to x, y, and z. This completes our tree with the remaining pairs, like 2x and 2y. Our third and final perspective is Visualization 3, Bipartite Mapping. Picture set A sitting on the left side of your screen, holding the numbers 1 and 2. On the right side, picture set B holding the letters x, y, and z. Now we draw elegant arrows connecting every single item on the left to every single item on the right. An arrow flows from 1 to x to create the pair 1x. We continue drawing lines, weaving a web to form 1z, 2y, and 2z.
mapping every possible connection between these two worlds. As our journey nears an end, let's discover a helpful shortcut in Step 4, the rule of multiplication. You might naturally wonder, how many pairs will we get in total? If you simply want to know the size or the cardinality of your new set, all you have to do is multiply the sizes of the original sets. Let's look at our example. Set A equals 1, 2 holds 2 elements, so we write A equals 2. Set B equals x, y, z holds 3 elements, so we write B equals 3. By using our simple rule, A times B equals A times B, we can easily see that 2 times 3 is equal to 6 total pairs. Let's bring everything we've learned together in our final summary. Putting it all together, our final set, the complete Cartesian product, is written mathematically like this. A times B is equal to the bracket 1x, 1y, 1z, 2x, 2y, 2z. Throughout this video, we explored 3 unique ways to understand this concept. We used a grid to clearly see intersections, we used a tree to visualize our many choices, and we used a mapping to see the direct connections. Thank you for joining me on this mathematical journey.